Hello everyone, welcome to Maths Wheels. In this session, we shall deal with polynomials, a chapter of class 10. In this video, we are going to learn about key concepts of polynomial. That is, introduction and basics of polynomials. Now, before we understand what polynomials are, we first need to understand what are expressions, what are terms, and what are coefficients. Now, to start with, what are expressions? Expressions are formed from variables and constants. Let's take an example, 2x plus 5. So this is an expression with variable x and constants 2 and 5. Let's take another example, 2x square plus 3x minus 2. So this is an expression with variable x and constants 2, 3 and minus 2. So what are all these? These are expressions. Now what about terms? Terms are the product of variable and constant factors, or we can say terms are the product of variable and constant. Now for the first expression there are two terms, 2x and 5. For the second expression there are three terms, 2x square, 3x and minus 2. If you observe term 2x, we can see it is the product of constant 2 and variable x. Similarly, terms 2x square and 3x. These are also the product of constants and variables. Now, what about terms 5 and minus 2? We can't see the variable part here, right? So, can we say these are terms or not? Answer is yes. These are also terms. Why? These are also terms. Because 5 here can be written as 5 into x raised to the power 0. And what is x raised to the power 0? It is 1. So we can say 5 here is the product of constant 5 and variable x raised to the power 0. Similarly, minus 2 here can be written as minus 2 into x raised to the power 0, which is nothing but 1. So we can say minus 2 is the product of constant minus 2 and variable x raised to the power 0. So here value of the term does not change even if we don't write x raised to the power 0. So it doesn't matter if we don't write x raised to the power 0. So that's about term. Now let's talk about coefficients. What are coefficients? The constant part of a term is called coefficient. For example, in the first expression 2x plus 5, what is the coefficient of x here? 2 is the coefficient of x. Now in the second expression, let's see 2x square plus 3x minus 2. What is the coefficient of x square? 2 is the coefficient of x square. And what is the coefficient of x? 3 is the coefficient of x. So that's a basic idea of the term. Now let's see how it helps us understand the polynomial, how we can define polynomials. Now if we look at the word polynomial, it has two parts. Poly means many and nomial means parts or terms. So polynomial is the combination of many terms. So what is the standard definition of polynomial? Polynomial is an expression with one or more terms, wherein we have two conditions, one for the coefficient and another for the exponent of variable. X should be non-zero and exponent of variable should be non-negative integers. So that's a standard definition of polynomial. It's an expression with one or more terms wherein coefficient is non-zero and exponent of variable is non-negative integers. Now let's take few examples. First, 3x square plus 5 root of x, c1 by x plus 2, 4x square plus 5x plus 6 cube, and 5x square plus 5. So these are few examples. Now if you want to verify if these are polynomials or not, how we will verify this? Based on the definition of polynomial, we will verify these two conditions, whether the coefficient is non-zero and exponent of variables is non-negative integers. If these two conditions are satisfied, then we can say the expression is our polynomial. Now let's take first example. Here we can see the coefficient of x square is 3, which is non-zero, and what is the exponent, that is power of variable x, it is 2. That means it is a non-negative integer. That means this expression is our polynomial. Now what about second expression? We can see the exponent of the variable. We can write this expression as 2x plus x raised to the power 1 by 2. Root of x can be written as x raised to the power 1 by 2. Here the exponent of the variable is a fraction which is not an integer. Hence we can say this expression is not a polynomial. In the third expression, we can write is 1 by x as x raised to the power minus 1. Now if you observe, exponent of the variable x is minus 1, which is a negative number. That means it is a not integer. Hence we can say this expression is not a polynomial. Now what about fourth expression? The exponent of the variable x here are non-negative integers. That means it is a polynomial. Now what about expression 5? Exponent of the variable is a non-negative integer. Hence we can say it is a polynomial. Now if you observe the last two expressions 4 and 5, we can see in the fourth expression only one variable is involved, that is single variable x is involved. Hence this is called polynomial in one variable. And in this fifth expression, two variables are involved. Hence this expression is called polynomial in two variables. Next important concept is degree of a polynomial. What is it? It is the highest power of variable involved in the polynomial. Let's take first example. 4x square plus 5x plus 2. What is the variable involved in this polynomial? X. And what is the power of the variable in the first term? It is 2. Now what is the power of x in the second term? It is 1. So which is the highest power of the variable? 2. So this 2 is called the degree of the polynomial. Similarly, in the second example, what is the power of the variable in the first term? 3. And what is the power of the variable in the second term? 1. Which is the highest power? 3. So 3 is the degree of this polynomial. Now let's take third example. In this we can see two variables are involved in each term, x and y. So how to calculate the power of the variable in first term? It is the sum of the power of variables. So what is the power of x here? It is 1. So what is the sum of variable? Sum of power of variable 1 plus 2, it is 3. What is the sum of power of variables in the second term? 1 plus 3, that is 4. And what is the power of variable in the third term? It is 1 plus 1, that is 2. So 3, 4 and 2. So which is the highest power here? 4. Therefore 4 is the degree of a polynomial. Now let's see how we represent polynomial. We have two examples given here. In the first example, we can see the variable involved is x. So we can represent this polynomial as p of x. Similarly, in the second example, y is the variable involved. Hence we can denote this polynomial as p of y. So you can take any variable like p of x, q of x, or q of y, depending upon the variable involved, we can denote the polynomial. Now let's see what is the general form of a polynomial of degree n. What is it? An x raised to the power n plus a n minus 1 x raised to the power n minus 1 plus a n minus 2 x raised to the power n minus 2 plus and so on, plus a0 x raised to the power 0. Where now if you see the last term here, x raised to the power 0 is 1, so we can write this general form as like this, so on a0, and what will be the term before this last term? It will be a1 x. So this is the general form of polynomial of degree n, where an should not be equals to 0. Now, what are an minus 1, an minus 2 here? These are coefficients in the polynomial. Now, if all these coefficients are 0, then all the terms in the polynomial becomes 0. So what will be the polynomial? P of x equals to 0. So if, let me write this, if all the coefficients an, a minus 1, an minus 2, if all these coefficients are 0 in the polynomial, then each of the term in the polynomial becomes 0 and the value of the polynomial becomes 0. So this is called the zero polynomial. This is called zero polynomial. Now, next concept is value of a polynomial. Suppose if we have polynomial p of x equals to x square plus x minus 2, and suppose if we substitute the value of x as 1, what will be the polynomial? P of 1 will become 1 square plus 1 minus 2. So P of 1 will become 0 when we substitute x equals to 1. So this P of 1 equals to 0. This is the value of the polynomial when x equals to 1. Now if we substitute the value of x as 2, what will be the value of the polynomial? P of 2 become 2 square plus 2 minus 2. So P of 2 becomes 4. So we can denote it as P of 2 becomes 4 when x equals to 2. So this is the value of the polynomial when x equals to 2. So how we can define the value of the polynomial? The answer which we are getting and substituting some value in variable of a polynomial, that value is called value of the polynomial. So if I want to generalize this, how can I do it? X is any, k is any real number, and if we could substitute k in the value of x, p of k will be the value of the polynomial. Now what is the zero of a polynomial? It is the value of the variable x for which value of the polynomial becomes 0. So it is the value of variable x for which value of polynomial becomes 0. So in the first example, in this example, we can say P of 1 becomes 0 when x equals to 1. So this x equals to 1 is called 0 of a polynomial, because when we substitute x equals to 1, the value of the polynomial is equals to 0. So if I want to generalize this x equals to k called 0 of a polynomial when P of k becomes 0. That means the value of the polynomial becomes 0. So this x equals to k is called 0 of a polynomial. Next we have types of polynomials. There are two classifications. One classification based on the degree and another classification based on the number of terms. Let's first see types of polynomials based on degree. First one is zero polynomial. Just now we learned when polynomial p of x equals to 0, then the 0 is called zero polynomial. And what is the degree of a polynomial? Degree is undefined. Why undefined? Because all the coefficients in the polynomial become 0 and all the terms in the polynomial becomes 0. So we cannot define the degree of a zero polynomial. Next is constant polynomial. A polynomial with only constant term is called constant polynomial. For example, 3. This is the constant polynomial. Next we can see 1 by 2. This is the constant polynomial. Next we can see minus 4, minus 5. These are the constant polynomials. And what is the degree of the constant polynomial? It is 0. Why 0? Because if you see this 3 can be written here as 3 into x raised to the power 0. 1 by 2 here can be written as 1 by 2 into x raised to the power 0. So what is the power of the variable here? 0. Hence 0 is the degree of the constant polynomial. Next we have linear polynomial. A polynomial whose degree is 1 is called linear polynomial. For example, 4x plus 5. What is the degree of this polynomial? 1. Hence this is the linear polynomial. Next we have quadratic polynomial. A polynomial whose degree is 2 is called quadratic polynomial. For example, 2x square plus 5. What is the degree? 2. Hence this is the quadratic polynomial. Next we have cubic polynomial. A polynomial whose degree is 3 is called cubic polynomial. For example, 2x cubed plus 5x. So this is the cubic polynomial whose degree is 3. Now in general, what is the nth degree polynomial? A polynomial whose degree is n, called nth degree polynomial. Now let's understand what are the types of polynomials based on the terms. That is based on the number of terms. First is monomial. Now what is monomial? A polynomial with single term is called monomial, with only one term. For example, x square. This is a monomial because it has only single term. Then we can say xy. This is a monomial. Then 2x cube. This is also one monomial. Now next type we have binomial. A polynomial with two terms is called binomial. For example, 4x plus 5. It has two terms, right? 4x and 5. So this is a binomial. Then another example, 2x cubed plus 4. This also has two terms and this is also a binomial. Third type we have trinomial. It has three terms. For example, 3x square plus 2xy plus 1. So this is polynomial with three terms, 1, 2 and 3. So this is a trinomial. Now in general, what is a multinomial? A polynomial with more than three terms is called multinomial. For example, we have 2x cubed plus 3x square plus 5x plus 7. So it has more than three terms. So it's a multinomial. So that's about the types of polynomials.